quiet, you. Okay. Shh. This is the second part of absolute value equations. Austin, please pick your head up. Okay, well, pick your head up. That'll help. All right. Yesterday we looked at what happens. This is still lesson
2-6 continue.
2-6. Yesterday we looked at what happens when you change the number in front of the absolute value bars and what happens when you change the number behind the absolute value bars. We said this is in the form of mx plus b. M tells us our slope. It tells us the direction that our graph opens in. It tells us if our graph is fat or thin. And the b, the plus 3 over there, tells us where this thing, our vertex, is on the y-axis. Well, I'm going to change the terminology now because b is no longer like b on a line. But that b term, plus 3, tells you how you move either above or below the y-axis. Because what we're about to do, the x-axis, because we're about to do is add a number in here that's going to take our vertex and shift it to the right or the left. Okay? So that's what we're covering today, and then we're going to put it all together. Let's see if we remember how to graph this. I put the point, the vertex, on 3 on the y-axis because it has been shifted 3 units above or up. And the slope is?
1, 2, 2, up 1 and out 2.
Up 1 and out 2.
Both ways.
Both ways.
Both ways.
So the graph of this function looks like this. Okay? That's from yesterday. Now, let's see how we move this thing to the left or right. When you put a number inside the absolute value brackets with the x, that is where your left and right movement comes in play. Okay. I didn't want to bombard with too much information at once. Okay? Now, notice that in this equation I have x minus x minus a. The equation is calling to subtract. Do y'all remember in the slope formula we had y1 minus y2? And we said if you subtract a negative number, what happens to it? It turns to addition. Well, the same thing here. The sign that is in front of that a term, whatever it is not a direct indication of which way you're going. It's the opposite. For instance, if this said x minus 1, I'm shifting to the right, not to the left. Because if I still have a subtraction sign here, then the number I'm subtracting is a positive number. And positive numbers go to the right. Okay? Okay. Well, let's look at this. This is still in mx plus b form. The 1 is inside with the x. What's the slope? 1. What's the y-intercept?
0.
0. There's no number there, so that's 0. Okay? But it's not really the y-intercept because look, this is what happens. On my graph, my original absolute value function, the standard function that has no shifts, no change in the slope or anything, sat here on the origin, correct? Yes, no, maybe so?
Yes, maybe so. Maybe
Okay. Now, my vertex always starts in reference to this origin. Does the vertex shift up or down? No. But does it shift to the left or right? Yes, and which direction does it shift?
Right.
To the right, the opposite of this sign, 1 unit. So my vertex is now here. Yesterday we took that V and we shifted it up and down. Now we're shifting it left and right.
So how'd you get it to shift?
Field goal.
So if it would be like x plus 1, it would be
To the left. It would have been to the left. Okay.
Why are you moving?
I'm lost.
Trying the x-axis?
Yeah, I'm lost too.
So if it be, so it's x minus 1, then you go to the right, it's x minus
Why?
x plus 1, you go to the left.
Why that's
Negative
so wrong?
Because, okay, let's stop and let's listen again to the explanation. Because the original equation said that we are subtracting a number from x. If you are subtracting a number and it's still subtraction, you have subtracted a positive number. Okay? If this was x plus 1, it means that I subtracted a negative number. And the negative number, this is actually, guys, this number here is the x coordinate of your vertex. This number here is the y coordinate of your vertex. So let's just make that a whole lot simpler. It's the x coordinate and the y coordinate of your vertex. So, if that's the case, where does my vertex sit? Where x is 1 and y is 0. Where x is 1 and y is 0.
So if it'd be a positive number, it'd be
Positive,
negative
it's
1.
not positive.
It's just like our.
We're going to do it. Hold on. So what's the slope?
1 over 1. Right.
Positive 1 over 1. There's your function. There's your function. Okay, now I'm going to put a few up here that have a slope of 1 and the y coordinate is 0. Okay? All we're going to mess with right now is the x, because I want the repetition to get there for you, so that as you see it over and over, it'll start to click. Okay, so all my slopes are going to be 1, and I'm not moving up or down. I'm simply moving left or right. Opposite sign of what's with the x.
So you go to the right, you go to the left.
Mine is.
Negative 3.
Negative 3. Oh yeah. Okay.
There's your vertex. There's your vertex.
There it is.
Your slope is 1 over 1. There it is.
Then it has to go to the side.
Why is he doing that?
How's it negative 1?
There's an arrow.
No, I
Keeps
thought I
going.
had to go to the side.
What if
I thought I had to turn to the side.
No. If it says x equals absolute value.
what if
Whoa.
y equals like 3? There's no slope.
Shh.
Like what if y equals 3 and it has absolute value x plus 3? That's the
I'm gonna get there. We're not putting this all together yet. We're taking it one step at a time. Okay?
Oh, so it's positive. And then you go up 1 and to the right 1.
Good job.
Okay. What's inside the absolute value brackets, because of the way the equation is written, it's the opposite sign of negative 2, so it's plus 2 on the x-axis.
This is only for absolute value.
Okay.
Actually, that's going to apply for circles, for parabolas, for ellipses, for all these other things.
If it said x minus 2 without the absolute value, it wouldn't do that.
No. Okay.
Right.